For number 9, limit as x approaches infinity. Here, if we have infinity to the 3/2, that's just going to keep getting larger and larger. This is going to get larger. The whole top is just increasing and approaching infinity. Same with the bottom. Take infinity times natural log infinity. This is just going to keep getting larger and larger. So again, top and bottom are both approaching infinity. So we can use L'Hopital's rule. Take the derivative of the top. We get 3/2 x to the 1/2 plus 5. On the bottom, we need to use product rule. So we get derivative of x is just 1 times natural log of x plus x times derivative of natural log of x is 1 over x. So we can simplify that a little bit. Top is going to stay the same, 3/2 x to the 1/2 plus 5 all over natural log of x plus 1. So we reevaluate this now. Limit as x approaches infinity. As x approaches infinity, this right here is still approaching infinity. Think about what a square root function looks like. A regular square root function looks like this. So as x gets larger and larger, the y value is still going to get larger and larger. So this top is approaching infinity. Bottom, we already talked about natural log of x. That graph looks like this. So as x gets larger and larger, the y value gets larger and larger. So it's still approaching infinity over infinity. So we have to try this one more time. So on top, if we take the derivative of this now, we get 3/4 x to the negative 1/2. Derivative of 5 is just 0. All over derivative of natural log of x is 1 over x. This one ends up being, if we take the limit as x approaches infinity up here, remember this is really like 3 over 4 square root of x, or x to the, let's leave it as x to the 1/2 for right now. Well, if we have like a number over x to a power, remember we talked about this up here, then the derivative of this is just going to be 0. Derivative of this one, also 0. So for this one, if we continued with L'Hopital's rule, what's going to happen?
You're going to keep getting 0.
You're going to keep getting 0 over 0. From now on, if we do like the derivatives of these, we'd get, this would be, like, this is like x to the negative 1, so our derivative of that would be negative x to the negative 2nd. This one is going to be another one that's, the x is always going to end up in the denominator. And as we approach infinity, that's going to approach 0. So this is going to be kind of repeatedly happening. If we do what Maggie mentioned earlier, we can kind of rewrite this. Let's look at it from right here. This is like x to the negative 1, right? We can bring it up here to make it x to the positive 1. And if we do x to the negative 1/2 times x to the first, we would just end up with 3/4 times x to the 1/2. Or 3/4 square root of x. And this limit would just be infinity. Or does not exist. But if we kind of keep doing that and get the 0 over 0, that's kind of our same result there. Limit's not going to exist.